Okay, what is the unit of work?
Of work.
Work.
That only, like I said,
Joule.
Newton meter or joule.
Joule. What is joule? What is one joule?
Joule is Newton meter only.
What does that mean? How much work is one joule? You have to apply how much force? 1 Newton force, and you have to displace it by 1 meter. Okay.
1 meter.
Okay. So 5 Newtons force, 2 meters is the displacement. What is the work done?
10
Very
G.
good. Excellent. Excellent. 7 Newtons and 8 meters. What is the work done?
56.
56. What is it? What is 56?
The joules.
Very good. This fellow, he's lifting 15 kgs. Okay. From the ground. And he's lifting to what height? 1.5 meters. So now what
Hmm.
is the work done?
115 into 10 into 1.5. 150 into 225.
Wait. Why 15 into 10?
Because it is they're raising it to a height of
Hmm.
to a height, so and we are using 10 Newton
What 10
uh,
Newton?
acceleration due to gravity wala thing.
That is G. Okay.
G.
Not Newton, that is. What is acceleration due to gravity?
10 Newton, no?
No. What are the
G.
units?
G.
G. What are the units?
Small
Small
g
g.
is Newton, big G
No,
is 6.673 wala.
no. Small g is not Newton. Force is Newton. But small g is acceleration due to gravity. What are the units of acceleration?
Meter per second square.
Right. Small g is what?
Meter per second square.
Okay. What is Newton?
Mm, Newton is I know, 1 second. Let me remember.
Yes. What is Newton?
Newton was momentum square.
What,
Momentum,
what, what?
momentum, and but it had square also.
No. What is Newton? Newton is unit of what?
Force,
What is force?
force, meter per area. Some. It was
No,
meter per second. Wait, just let me remember.
what is
Uh,
force?
F. Oh, it
F
was
equals?
like F
Uh,
equals
uh,
momentum minus into V minus A upon T.
that is m into v minus a by t. V minus u by t. Okay. Force is mass
Yeah.
into acceleration, right? Or change in momentum.
Yeah.
Okay, mass into acceleration. What is mass?
What is mass? Mass is
Units. What are the
u-
units of mass?
unit of mass Newton.
No. Unit of mass. There is weight.
Kilogram. Kilogram.
Right. Unit
Kg
of mass
meter per
is
second square.
excellent. What is Newton?
Kg
Kg
meter per
meters per
second.
second square. What is mass? Unit of mass.
Kg.
What is unit of weight?
A Newton.
Newton. Okay. Weight is force. Okay. Mass
Yeah.
is kg. Right. Mass is a measure of
Inertia.
inertia. Very good. Excellent. Okay. Now 15 into 9.8 or 15 into 10 we are doing for what? Because we are given mass. What we want? We want weight. Why weight? Because weight is a force. Okay.
Okay.
Okay. So there is a 15 kg mass. Okay. Let's say this box itself is 15 kgs. What does that mean? There is weight. What does that mean? Weight is the force by gravity on this object, right? Earth is pulling this down with a force of how much? If this is 15
9.8.
kgs, if 15 kgs, Earth is pulling it down. What does that mean? What
9.8 Newton.
9.8 into 15. Okay, 15 into 10. Earth is pulling it down with a force of 150 newtons. Agreed?
Yeah.
Okay, if someone's weight is 10 kgs, what does that mean? Earth is pulling that down with a force of how many newtons?
10.
10 into
9.8.
100. 10 into 10, 100. Right.
100.
Force equals mass into acceleration. In this case, Earth's acceleration due to gravity is g. Okay, F equals mg. So it means Earth is pulling it down with a force of 150 newtons. Okay.
Yeah.
Now, if you have to lift this up, what you have to do? You have to at least balance this force, no?
Yeah.
You have to apply a force in the opposite direction. What is the force you have to apply? 150 newtons. Okay. And what is the displacement that you have to do? 1.5. So that's it. That 150 into this 1.5. Okay, ma?
Yeah.
Okay. When do we say that work is done?
Work is done
Hmm.
when
Hmm.
yeah, that when force is applied and an object is
Right.
displayed and
See.
force
This is a
applied on
condition.
object.
This is a condition. When do you say work is done?
Work is done when force should act on an object and
Yes.
the object must be displaced.
Object must be displaced. Otherwise, if force is acting and the object is not displaced, work done is zero. Right?
Yeah.
Force should act. At the same time, object should be displaced. If the object is continuously moving without an external force, because it keeps moving, right? That is not work. Okay?
Okay.
Okay. 1 joule of work, you know. Okay. Fourth question, tell me.
Where of bullocks exert a force? 140 into 15.
Very good. Excellent. Excellent. What is energy?
Energy is by the intensity work is done,
Wait. Okay. What are the units of energy?
not joules.
Energy is also joules. Okay. Energy is also joule. Okay. What are the units of work?
Units of work are joules, and this is also joules.
This is also joule. What does that mean?
What does that mean? Both
That
have
means work units of energy and units of work are same, right?
are same. Yes.
Are same. What does that mean? If you are doing some work, what does that mean? You are transferring
Energy.
energy. Excellent. You are transferring energy to something, someone. Okay.
Yeah.
Okay. So energy and work are related. Okay. Now continue reading. Read
Life is
this.
impossible without energy. The demand
Hmm.
for energy is ever increasing. Where do we get energy from? The sun is the biggest natural source of energy to us. Many of our energy resources are derived from the sun. We can also get energy from the nuclei of atoms, the interior of the earth, and the tides. Can you think of other sources of energy?
Hmm.
The word energy is very often used in our daily life, but in science we give it a definite and precise meaning. Let
Hmm.
us consider the following examples. When a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. Similarly, an object when raised to a certain height gets the capability to do work. You
Hmm.
must have seen that when uh, raised hammer falls on a nail placed on a piece of wood. It
Hmm.
drives the nail into the wood. We
Hmm.
have also observed children bending a toy, such as the toy car, and when the toy is placed on the floor, it starts moving.
Hmm.
When the balloon is filled with air and we press it, we notice a change in its shape.
Hmm.
As long as we press it gently, it can come back to its original shape when the force is withdrawn. However, if we press the balloon hard, it can even explode producing a blasting sound.
Hmm.
In all these examples, objects acquire through different means the capability of doing work. An
Hmm.
object having the capability to do work is said to possess energy. The object which does the work loses energy, and the object on which work is done gains energy.
Understood. So when you are doing work, you lose energy. Okay. And when you are doing work, essentially what you are doing, you are transferring your energy to something else. Okay. So,
Yeah.
for example, a hammer is hitting the nail. Who is losing energy here? Hammer is hitting the nail. Who is losing
Hammer
energy?
is hitting the nail, so hammer is applying force.
Has
Hammer is moving energy.
hammer is losing the energy. Okay.
Yeah.
And who is taking that energy?
Nail.
Nail is taking the energy. Why is hammer losing? Hammer is at a certain height. It has dropped down, so it has lost some potential energy. Right?
Yeah.
Okay. At a certain height, that means there is some energy. Right?
Yeah.
Okay, so let's say if a ball falls on a mirror, okay, on a glass, and the glass breaks, who gave energy to whom?
The first one gives the energy to
The
second.
ball gave energy to the glass. Okay,
Yeah.
okay, here the children are winding a toy. Who is giving energy to whom?
Children are giving to toy car.
Children
Toy.
are giving to toy car. Very good. Okay, so basically, what are the, okay, tell me different forms of energy, some random. Different
Heat
forms of
energy,
energy.
kinetic energy, electric
Hmm.
energy, potential energy, chemical energy,
Lot of
geothermal
energies.
energy.
Lot of energies. Light energy, whatever energy, chemical energy, etc. etc. Okay. And of these energies, some energies are important, like mechanical energies. Okay. Okay. Now tell me, what is kinetic energy?
Kinetic energy is the energy possessed by a moving object.
Yes, 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 yes. Very good. Okay. Objects in motion, they possess energy. Right. Object in motion, it possesses it possesses some energy. What is that energy called? Kinetic energy. Okay. So what does that mean? A moving object can do work. So what does that mean? What is doing work here? If you move some body from some place to another place, you are able to move a body, that means there is work done, right? Agreed. A moving
Yes.
object, if you put on its way some small object, it will move that object also, right? So that means that moving object has got some energy, okay, and it has got the ability to move some other object, right?
Yeah.
Okay, so that means the moving object has got energy. If it is a stationary object, it cannot move others, right? If it
Yeah.
is moving, it will be able to move others. Okay, that means moving object has got energy. What is that energy called?
Kinetic.
What are the units of it?
Um. We just did it. Where just
Units of kinetic energy.
joules only.
Joule only. Okay.
Okay.
Okay. Kinetic energy is the energy possessed by an object due to its motion. If the motion stops, energy is no longer there. Okay.
Yeah.
Agreed. Now, how much energy is it present? Okay. Fast moving object will have more energy or slow moving object? Which one will have more energy?
The
No,
one with
faster object or slower object?
the one with more speed. So
Which more? Oh, okay. The one which is traveling faster will have more energy. Which object has more energy? The heavier one or the lighter one?
the lighter one,
Why lighter one?
because of the
No, no. A heavier fellow will be able to move some other object, or a lighter fellow will be able to move some other object.
heavy.
What? Heavier, right? So heavier the object, it will be able to move, right? If there is a small plastic ball versus a big football. Okay,
Yes.
the plastic ball, even the both balls are moving at the same speed, the plastic ball will not be able to move any object, right?
Yeah.
But the heavier football will be able to move some objects, right?
Yes.
So that's why which one has more energy?
Football, like the heavier object.
Heavier object. At the same velocity, heavier one will have more energy. When two objects have the same mass, who has more energy? Whoever has the higher velocity has the more energy, right? Okay, ma?
Yeah.
Okay. Now, work done is force into displacement, right? Okay. Now,
Yes.
let us assume you applied some force, and when you apply some force, you get some acceleration, right?
Hmm.
If you get some acceleration, what does that mean? Your velocity will change, right?
Yep.
Let's say velocity will change, if there is an acceleration. If
Yes.
there is an acceleration, that means obviously velocity changes, no? Otherwise, there is zero acceleration, right? If there is some acceleration, means velocity has changed. Okay? Let's
Yes.
say, let's say the velocity has changed from u to v. Okay? Okay?
Yeah.
And u to v over a distance of s. Okay?
Okay.
Okay. So you know this formula, right? V
Please
square
come.
minus u
Yeah.
square equals to 2as, right? What are the other two formulas?
Yeah.
Do you remember?
Yeah, I remember.
Okay. Tell me.
Ut plus half at square equals
Ah,
s.
very good. Excellent.
Um,
What?
v equals u plus 80.
Excellent, excellent. Okay. So now, if an object has gained some velocity, okay, it started at velocity u and gained at velocity v, reached velocity v in a distance of s. Okay, and what is the acceleration? We get it like this, right? V square minus 2a square equals to 2as. Okay, that means a equals to or s equals to v square minus v square by 2a, right?
Yeah.
And we know force equals mass into acceleration. Okay. And what is acceleration? Acceleration is v
Like
square
v
minus u
square
square by
minus v square upon t.
ah. Okay, okay. So mass into acceleration. Sorry, force equals mass into acceleration, right? Now what is work? Work equals force into displacement, right? Force is ma and displacement is again v square minus u square by 2a, right?
Yeah.
This a and a will get cancelled. What is the work done?
1
Half
by 2
m
and v
v square
square.
minus u square. What does that mean? If object is initially at 0, okay, u is 0 and it reaches some velocity, okay, so what does that mean? What is the work done to get this energy? If object starts at 0, okay, and reaches a velocity v, that means it has gained some energy, right?
Hmm.
Earlier it was resting, that means there was zero energy. Now it has gained some energy. Okay, u is 0, that means it has reached this energy, right?
Yeah.
Okay, it has reached this energy. Who gave that energy? Whoever has pushed the given the force, right? That fellow has given this energy, right? Okay.
Yeah.
Now, what does that mean? If the object is moving with this velocity v, that means it has got already this much amount of energy, right?
Right.
Agreed? Okay. So, because someone has spent this much energy to get this fellow's velocity till here, obviously all this energy will be with this fellow. Okay.
Yeah.
Agreed. So what exactly is this kinetic energy? That is half mv square. If an object is moving with velocity v at a certain point, what is the energy that it has? What is the kinetic energy it has? Half mv square. Okay.
Yeah.
Okay. Now tell me the answer of this problem.
Of mass 15 kgs moving with, okay. 1 by 2 into 4 into 15. 1 by 2 into 15 into 16. 120?
How much?
120 J?
Why 120? 120 j. Okay, half into m into v square. Okay. Okay.
Yeah.
Now this is interesting. The velocity is increased from 30 to 60. Okay. Mass of the car is 1500. Now, what is work done? Okay, you're increasing velocity from this to this. Okay, you have to be little careful here. There is, please be careful with the units. Okay,
Yes. Mm, I don't understand this one.
okay. So, what is it saying? The velocity has increased from 30 to 60. Okay, but first of all, this is in kilometers per hour. Okay, what we want? We want SI units, that means meters per second. Right? How do you convert kilometers per hour to meters per second?
Kilometers per hour to meter per second. Into 5 by 18.
5 by 18, excellent. Okay, if you convert u and v, first of all, you will get in terms of meters per second. Right. The car mass is this thing, and initial velocity is this, final velocity is this. That means initially how much energy it has got? Half into 1500 into whatever, this square. Right? Half into 1500 into 25 by 3. What is 25 by 3? 30 kilometers per hour is 25 by 3 meters per second. Right. This is the original energy it has got. Right. Now you have increased the velocity to this one. What that means? What is the new energy? That is this one. Agreed? Half into mass into again v square. This is half into mass into u square. Agreed, ma?
Yeah.
Initially, it has already got this energy. Now you have supplied some more energy to make it this much. So what is the energy that you supplied? This much. The difference, right?
Yeah.
That is the additional energy that you have given. Okay? That means the additional energy that you have given. What does that mean? You have done work, right? Otherwise, how can you give energy? You have done some work. Whatever additional energy that you have given is the energy that you have spent. That means the work was done by you. Okay? So what is the work done? The difference between final energy and initial energy. Agreed?
Yeah.
Okay? Can you do this and tell me? Can, can you quickly do this and tell me whether your answer is matching this or not?
Okay.
Understood now?
No, just a second. I'm just writing it now.
Okay, okay.
Done.
Okay, very good. What is the kinetic energy of an object? What is kinetic energy?
Oh, I was on mute and I was talking. I was saying when any object is in motion,
Hmm.
it possesses energy. This energy is uh, kinetic energy.
Energy possessed by an object by virtue of its motion. Okay, that is called kinetic energy. Excellent. Okay, tell me what is the expression of kinetic energy of an object?
Mm, I don't know.
You know.
What 1/2 mu square is
That
expression?
is that one only. Half
No,
mv
that's
square.
expression.
That is the expression half mv square. This one only.
Okay. I thought it's like formula, not expression.
Okay, that is this one. Okay.
Yeah.
Now, kinetic energy of an object is moving with the mass of the object is m. It is moving with velocity 5 meters per second square. And what is the energy? 25 joules. Okay. Now, can you tell me what exactly is its mass? Half mv square equals to 25. What is m?
One second, I'll
Can you
write it.
calculate and tell me half mv square equals to 25?
1 by
V is
2.
given 5. What is m?
Just a second, I'll write it down over. M by 2? No, wait, what? M
Uh,
equals 2?
what?
M is 2.
Why is m 2? Tell me.
After doing the calculation,
What did you do the calculation? Half into
M into 5 into 5.
half into m into 25 equals to 25, right?
Yes.
Okay, so
So
25 and 25
so
will get cancelled.
25 cut and M equals 2.
M equals to 2. 2 what? What are the units?
Oh, joules. No, not joules.
Uh,
Kg.
2 kgs, very good. Now, your kinetic energy is doubled. Sorry, your velocity is doubled. That means what? What is the new velocity?
10.
Okay, 10. What happens to the kinetic energy?
M equals 1
M
by 2.
equals M is anyway same.
Oh, kinetic energy.
M is anyway 5. Your velocity has become instead of 5, it has become 10. So what is half mv square? Half into 5 into
100. 100.
10 into 10, right?
100 is the kinetic energy
Why 100?
because 1 by 2 into 10 into 1 by 2 into 2 into 10 into 10.
Very good, excellent. So that should be 100, right? 100 is your kinetic energy. Earlier, what was your kinetic energy?
Yeah.
First case, 25, right? 25 has become 100, right? What does that mean? Kinetic energy has become how many times?
15.
No, not 15. 25 to 100.
Acha, 25 to 100 first time 4 times.
4 times, okay? So that means what? If you double your velocity, your
Then 4
kinetic
times.
energy will become 4 times. What if you triple your velocity? Can you try that? Instead of 10 meters per second, you have tripled it. That is 15 meters per second. What will happen?
1, 2, 2. 15 square.
15 square, how much?
225.
225 by what was the original one?
Original one was 100.
No, original was 25.
अच्छा एकदम original one was 25 years.
That's what you have to compare, no? Okay.
Okay.
If you do velocity three times, then what is our energy becoming?
9
Nine
times.
times. Okay. So basically, if you increase velocity by x, your energy will become x squared. Okay. If you increase velocity by 4 times, your energy will become 16 times. If you increase velocity by 10 times, your energy will become, tell me,
Um,
10 square. What is 10 square? 100 times. Understood?
yeah.
If you increase velocity by 4 times, what will be your energy? Energy will become 16 times. Okay, ma?
Yes.
Okay? Okay. Now, tell me what is potential energy?
Potential energy is like the energy possessed by no.
Hmm.
Like when an object is to be dropped from air,
Hmm.
like spring possesses that energy. It's some virtue or something, right?
Virtue. What is virtue? Which virtue?
Acha, like kinetic energy is virtue of motion, and this is virtue of position.
Virtue of position or configuration. Okay? Can you give some examples?
A spring,
Spring.
that slinky,
That's
slinky thing,
slinky. Slinky is.
and I don't know
Okay. So
more. I don't.
spring has got energy. That's what you are saying. Okay. How do you say spring has got energy?
Spring because like when we like pull towards one end,
Hmm.
so those like in the second end also.
Yeah, so it will try to if you see if you stretch the spring, what it will do? It will try to pull you, right? It has got the capacity to move an object, right?
Hmm.
Okay, so this bow, it has got the capacity to send an arrow, okay, to move an arrow through a displacement. Basically, it can give some force and give some acceleration to this arrow. Similarly, spring also. Okay,
Yeah.
so they have got the ability to do some work. Okay, if let's say this arrow, this bow is not stretched, this is flat, then will it have the ability to send this arrow? No, right? If it is not stretched. Okay,
Yes.
so ability to move some object through some displacement is energy, right? If this is not stretched, it will not have the energy, right?
Right.
Okay, it cannot do work. What is work? Moving an object through some displacement, right? Applying
Yes.
some force and moving an object. Okay, when it is stretched only, it can apply some force on the arrow and can move it through a some displacement.
So can
But
we see like when force is applied on an object with potential energy, it
hmm,
has the ability to make another object do work.
yes, okay, it can do work. It basically it can itself do work. That's why it will be able to move the arrow. Okay, ma?
Yeah.
Okay. Now, what is there are a lot of potential energies. Spring has a potential energy, arrow, bow has a potential energy, etc., etc. Okay. So currently we are interested in potential energy because of height. Okay. Okay. If an object is at a height, it has got the ability to pull someone up or something down, whatever. Right.
Yeah.
Okay. So object at a higher position, it has got some energy. Okay.
Yes.
Okay, versus an object at a lower place. Okay, so for example, if there is a pulley here, okay, if there is a pulley here, okay, if you tie a string around that pulley, then this object can actually pull some other object lying here up, right?
Yeah.
Agreed? This
Right.
object can actually go down and pull this one up, whereas this object cannot do that, right? That's why this object doesn't have the energy. This object has the energy to pull someone up, right?
Yes.
And by the time of pulling, it itself loses some energy, right? It is actually giving the energy to this object while
Right.
pulling it up, right? Agreed.
Yes, sir.
Okay. Now, now read what is he saying. Read what is he saying.
An object increases its energy when raised through a height. This is
Hmm.
because work is done on it against gravity while it's being raised. the energy present in it, in such an object is the gravitational potential energy. The gravitational potential energy of an object at a point above the ground is defined as the work done in raising it from the ground to.
Okay. So now, uh, this one, when this object is at certain height, it has got some energy. Okay. But the question is, who gave that energy? How did it first, in the first place, how did it get the energy? Who gave that energy? Whoever has lifted the object from ground to that place, that fellow would have given the energy, right? Hello. Can you hear me?
Sir, I don't know
Hello.
what
Can you hear
happened.
me?
Yes, sir, my laptop just shut down.
Ah, okay, okay. So now, tell me, when an object it is raised up, okay, this object is here. That means it has got some energy. Okay.
Yes.
Now, in the first place, who gave this energy?
Uh, Due to height, it got this
Ah,
energy.
right. That means whoever has lifted that object right from here to here, that fellow would have given that energy, right? If you have lifted this object from here to here, that means you have lost some energy, right? You have spent some energy in lifting the object. So where did this energy go? That energy went here. Okay. When you are lifting an object from here to here, you are spending some energy, right? That energy you have given when you are spending means you have given it to this object. Okay. Now, if this object comes down, okay, by pulling this one up, that means this is losing it this energy and giving it to this one. Okay. Now, if this fellow comes down again, this is losing this energy and giving it back to this one. Right?
Okay.
Agreed. It is like this. Okay, ma?
Hmm. Yeah.
Okay. So now another. Okay. Continue reading.
Should I read the box
Ah,
also?
yes. Yes, read on
Potential
also.
energy of an object is at a height depends on the ground level or the zero level it reaches. An object is in a given position can have a certain potential energy with respect to one level and different value of potential energy with respect to another level. It is useful to note that the work done by gravity depends on the difference in vertical heights of the initial and final position of the object and not on the path along which the object is moved. Figure 11.8 shows a case where the block is raised from position A to B by taking two different heights. Let the height AB equal h. In both situations, the work done on the object is mgh.
Hmm. So what it is saying? It work done it depends on what is the zero level or the potential energy depends on what is our frame of reference, right? Agreed.
Hmm.
So
Yup.
for example the frame of reference is important. So for example, if I say what is the distance to your school,
Um, so can you repeat that? Your voice was very muffled.
What is the distance to your school?
I don't know.
Okay, so when I say distance to your school, means your immediate question is distance from where? Is it from my home or from that road or from the airport or whatsoever, right?
Like reference point.
There should be a reference point, right? Otherwise, if I plainly ask distance to your school, it is meaningless question, right?
Yeah.
It could be anything. For instance, when I say distance, it should automatically mean there should be a reference point. Distance from where, right? So similarly, potential energy also. When I say potential energy, it obviously means there should be a reference. Potential energy with respect to what? Okay,
Yeah.
with respect to what? Otherwise, it doesn't mean anything. What is potential energy means with respect to what? When I say distance to your school, then I might automatically mean that the distance is from our home. Okay, when we are talking distance to your school means I might not say it, but I automatically mean distance from your home, right? Similarly, here also, generally when we talk about potential energy, we automatically mean the potential energy with respect to the ground level. Okay,
Okay.
okay, generally, okay, ma. But potential energy means with respect to some reference value. Okay, generally we take the reference value to the ground one. Okay,
Okay.
okay. Now tell me what is the answer for this?
Energy possessed by an object of mass 10 kg when it's at a height of 6 kilometer. Uh, 10 is 60 into 9.8.
16 to 9.
60.8.
Wait. 16 to 9.8.
Oh, sorry, 16 to 9.8.
It is not 60.8, no?
608. No, sorry, what?
Okay.
588. Yeah, I was doing wrong calculation.
Okay.
5880.
Very good. Excellent. Excellent. Do this one.
4. 4 is the height.
Why 4?
Because like 12 into 10 is 120, 480 divided by 120 is 4.
4 what? 4. What 4?
4
Units.
meter.
4 meters. Okay. Very good. Okay. Next important question. Okay. What is law of conservation of energy?
Law of conservation of energy. I don't think this is coming.
Are you sure? I think it was there.
Last time I'll just check. I'll confirm.
Just check. I
Um,
think this is there. Power is also there. We did last time power also, right?
Power we did, but I think this was not
That is
there.
law of conservation of momentum is not there, I think. Energy,
Okay.
just check.
Because like in this chapter I remember something was not there.
Okay, just check.
Hmm, I can't see it. Wait. Science. It's not written in this. It was in another. I don't. No, in the syllabus I have, it's written. Nothing is written about it because it got changed. So I don't have the new one. It's with my mother.
Okay. So otherwise, let's do one thing. If it is there, we will revisit this again. We'll continue with power. Okay.
Okay.
Okay. Now tell me what is power.
Rate of energy with work done. Something like that.
What does that mean?
Like with how much some strength. No. How much something we have energy with.
Hmm.
I don't know how to explain it.
Okay. Let's say there are two persons. Okay. Okay. So what is work done? Tell me. If you have to move, one object. Okay, of 1 kg, 1 meter. What is the work done?
2 kg object.
1 kg object, 1 meter you have to move.
1 joule. 1 kg object. 1 meter you have to move.
Hmm.
1 joule.
Okay, so work done. Okay, earlier we had done now the first question. Ah, Okay, some force, this force is moving this object 8 meters. Okay, there is a force. Okay, this force is moving this object 8 meters. What is the work done here?
4 7 meter displacement.
Okay, 7 into 8, 56, right?
56.
Okay, so now this fellow is spending how much? 56 joules of energy, right?
Yep.
Okay, now to spend, there are two ways of spending, let's say this 56 joules. The first way is spending this 56 joules in 10 seconds, second way is spending this 56 joules in 2 seconds. Okay,
Okay.
okay, what does that mean? What is the difference? Spending 56 joules in 2 seconds versus 10, spending 56 joules in 10 seconds?
2 seconds, we are spending it faster.
Spending it faster, right? He's spending it faster. What does that mean? The object will move 8 meters very fast, right?
Yeah.
So in both cases, object will move 8 meters. Agreed? In both cases, because you are spending 56 newtons, obviously the body will move 8 meters, right?
Yes.
But once if you spend it fast, the body will reach in 2 seconds. But if you spend it slow, the body will reach 8 meters in 10 seconds, right?
Yep.
Agreed. Agreed.
So faster.
It is faster. Like say for example, a high-end car versus a low-end car. Okay, both will reach destination, right? Both will reach destination, but the high-end car will spend more energy in a shorter time. Agreed? And
Yeah.
it will reach destination little faster. Okay, that's what that is happening. Okay, it is spending energy in moving an object little faster, right? If if you have to walk, then also you will spend energy. Okay, but you'll spend energy over a longer time. If you run, what is happening? You are spending energy over a shorter time. Agreed?
Yes.
You will still reach the destination. Whether you walk or you run, you will still reach the destination. But what is the difference?
Faster.
You will reach faster. What does that mean? You are spending the same energy, but in a shorter duration of time. Okay? So, power is all about in how much duration you are spending the time. Sorry, in how much duration you are spending the energy. Okay, ma?
Yeah.
Okay, so let's say there is a donkey versus there is a horse. Okay, you know donkey, you know horse, no?
I know donkey and horse, yes.
You know donkey and you know horse. Okay,
Yeah.
so the horse will reach destination faster than the donkey, right? Okay,
Yes.
so that means so same destination, same distance, it can run faster, it can apply force faster. Okay, that means horse is more powerful than donkey. Okay, as per science, horse is more powerful because horse can spend energy faster. Okay, whatever you do, a donkey or a camel, they will not be able to run that fast. Okay, that means they don't have the ability to spend energy faster. Okay, you understood?
Yes.
Okay, so for example, a AC or a fan rated whatever some power at a higher power will be able to spend energy faster.
Faster.
Okay, some
Yeah.
whatever some engine which is rated at a lower power versus a higher power will not be able to spend energy at a faster rate. Okay, ma? So
Yeah.
power is all about how fast you are able to spend energy. Okay, if it is an electric appliance, let's say if it is a geyser or something, how fast you are able to spend electric energy and heat the water. Okay,
Yeah.
okay, you should be able to spend electric energy, right, to
Hmm.
heat the water, right? If it has a higher power, what does that mean? It should be able to spend the energy faster and heat the this thing. It should be able to spend energy faster and make the object move. Okay, reach destination faster. Okay, ma?
Yes, sir.
Agreed. So that is power. Power is defined as what?
Power is defined
Rate
as
of
the
energy.
rate of
Okay,
doing work or rate of
rate of
transfer of
transfer of
energy.
energy. Okay,
Yeah.
that is power. Who has higher power? Who can spend faster?
Work upon time,
Ah,
basically.
who can do faster work? Okay, work same more work in the same time. Okay,
Yeah.
that fellow has got higher power. Okay, so what is the unit of power?
What?
Watt. What is what? Joule per second. Okay.
June 2nd.
Now in the in lot of electric bulbs or geysers, you would have seen this watt, 100 watt bulb, 15 watt bulb, like this. Have you seen 2000 watt heater? This kind of things. Have you seen
Yes.
2000 watt geyser or 1000 watt geyser or 20 watt bulb, 15 watt bulb, whatever?
Yeah, I think I have seen it. Not sure. I think I have.
Okay,
Most probably.
15W bulb or 20W, whatever you would have seen. Okay, what exactly is that? How
There.
fast that appliance can convert electric energy. Okay, the higher watt means it should be able to convert faster. Okay, obviously. So what does that mean? It either the bulb would be brighter or appliance would be faster. It will convert faster electric energy and to give better light or better heat or whatsoever. Okay, or better speed or anything. If a car has got higher power, what does that mean? The car can run faster. If a light has higher power, what does that mean? The light can run brighter. If a mixer has higher power, what does that mean? Mixer can run faster. Okay, fan has higher power. What does that mean? The speed of fan could be higher. Okay, ma?
Yeah.
Okay, now do this thing.
Okay. 3200 upon 20.
Why 3200? Force Newton
Because
into displacement is the total energy.
yeah,
Okay, the total
3200
energy, this fellow
upon
is taking 20 seconds, that fellow is taking 50 seconds.
so
So, whoever is spending the energy faster has got the higher power, right?
yeah,
Okay, 3200 by 20 seconds. This fellow has got
160.
160 watt power. What is the other one? Other one is a slower fellow. So that fellow can spend only 64, right? So the power of second girl is actually much lower than the first girl. Okay, ma? Understood now? Okay. Now this one you do.
Um, 45 steps in 9 seconds. Height of each step is 15 centimeter. Find a small. Okay. So I think 1 second. 15 into 10. No.
45 steps. Each step is 15.15 meters. So what
45
we
into
explained to
15.
point that is 6.75 meters is the displacement. And what is the weight? Mass is 50. So weight should be 15 to 10. The force is actually 500 newtons. Okay. Force into displacement. Okay. Force into displacement is 500 into 6.75. Okay. And this is the energy that he has spent. And within how much time? Within 9 seconds. Okay. So this fellow's power is what? He can spend he can spend this much energy within 9 seconds. So what is his power? 375.
375 volt.
375, not volt. It is watt.
Watts, not
Watt.
volt.
Volt is
Watt.
different. Okay, ma?
Yeah.
Okay, what is power?
Power is okay. Power is weight up work upon time.
Work upon
Um,
time. 1 watt of power is?
1 watt of power is 1000 J.
No, no,
Sorry,
not 1000.
what am I saying? No, no, no. It
1
is
joule
joules
per
per
second.
second. J by S.
Okay, okay. This one, third one, what is the power?
100.
100. Very good. Okay, what is average power?
Total work upon total time.
Total time. Okay, very good. Total work done by total time. Okay, ma? Cool.
Yeah.
So we'll stop here. You do the revision. Okay. Which all chapters we still have to do revision? I think we have done revision one round at least for all the chapters, no?
Yes, sir.
Okay, okay.
We've
So
not done the first chapter.
what, ma?
First chapter.
First chapter is what?
No,
Atoms.
sorry, I mean physics ka first. Motion. No.
Atoms, physics, that all is done, no? Biology you will be able to handle, no?
Yes. We haven't done motion, I'm saying.
Which one?
Motion. First
Motion we have
physics.
done, no? Newton's laws of motion. Yesterday
No,
only
no.
we did.
Not force, motion.
Acha, acha, UT plus half a d square wala motion.
Yeah, that one.
That we will do. Okay?
Okay.
Next we will do that chapter, okay? Next
Okay.
class.
Bye,
Okay,
sir.
just finish off this chapter. There is some, this one more section is there. That's it. Just close this chapter, okay? and keep revising. All chapters you do revision once. Chemistry also you do
Okay,
revision once. Okay?
okay, sir.
Okay, Amma. Take care. Bye bye.
Bye, sir. Thank you, sir.
Bye, Ma.